Hello, CHistrue here. This is going to be a series on what I would consider to be basic scientific literacy. We have in our society apparently 18% of the people don't believe that the Earth goes around the sun. And the purpose of this video series is to address people directly to you. Those of you who, let's say, are adults and have gone through the education system and don't believe that the Earth goes around the sun. And maybe to address some of your views about science, and maybe you honestly don't understand the science. Maybe you don't understand how it is that the Earth can move and we wouldn't feel it. Okay, or you don't understand, let's say, on the question of evolution. It's not so much that you have a religious objection to evolution as you honestly don't understand how a dinosaur could become a bird. That doesn't make sense to you, or how some primate-like creature could become a person. That doesn't make sense to you. And I want to address these questions from a common sense perspective. I'm going to be presenting the scientific consensus and explaining it in a way that hopefully will make a lot more sense than the way the education system presents it, which is through facts and figures and complicated things, and then if you don't do well on the test, you're made to have low self-esteem, and honestly, the entire education system needs to be revamped. Nobody needs any of that. So this is for people between ages 25 and 125 who need to bone up on their scientific literacy and know it, and are embarrassed to go to a college professor or anybody and ask questions that the audience will think is stupid. So by all means, I have moderated comments you can post, or you can PM me if you have questions. This is not intended for these audiences. If you were insulted by the idea that I would think that you don't know the Earth goes around the sun, this video is not intended for you. This is intended for people who honestly don't understand, and they've gone through the education system and they don't understand how it could be that the Earth goes around the sun. This is honestly for whom this is intended. So if you feel insulted, don't watch it. It's not for you. But actually, I only encourage you to watch it for one reason, and that's to correct me on my facts, because I'm going to do the best I can here. But if I flub a certain kind of fact or figure, by all means, correct me on that. But other than that, this is not for you. I mean, it's honestly, you can skip this one. Regular subscribers, by all means, skip this. Okay, that's fine. It's also not intended for people under a certain age. If you're in high school or college, you're welcome to watch it, but this is not going to help you pass the course necessarily. I mean, it's not. And also, if you're studying for your GED, this is not necessarily for you. You're welcome to watch it, but this is not the Khan Academy. This is not. Khan Academy is a standard bearer. I cannot compete with them. This is also not going to have a lot of wowie zowie special effects. And there's a reason for that. I want to keep this conversational. For one thing, I don't know how to do all those things. But second of all, if I have to convince you through wowie zowie special effects, then the skeptic in me would say maybe there's something wrong here. Come on, this guy's claiming the Earth moves and he wants to convince me through wowie zowie special effects. I'm more likely to be skeptical. So I'm going to convince you that relative to the sun, the Earth is moving just through the best kind of logic and common sense that I can. Then I'll move on to other scientific subjects as I can. Finally, this is not intended to debate any kind of religion. If you don't believe that the Earth goes around the sun because your religion teaches you that that's false, I can't convince you. Don't bother contacting me. I'm here to deal with the people who have an open mind, who want to learn some basic facts about the solar system. So, all right, I might have to go to part 2 on this if I can't get it done in a good amount of time. But we're going to jump to the solar system right here on the CHistrue channel. For those of you who, again, are part of the 18%, or just maybe you want to review. All right. According to the old model of the solar system, yes, the Earth was the center of the solar system. This was the Aristotelian view, where they actually knew the Earth was round in the Middle Ages. It's not true that Columbus proved the Earth is round. They knew the Earth was round, but they figured that the center of the Earth was also the center of the universe. And that what we call gravitation is really the pull of all matter towards the center of the Earth, which is, again, the center of the universe according to the medieval view. And you had various, what would be called, various shells where the astronomical bodies would be aligned according to the various shells. But Nicola Copernicus noticed that something was wrong, and that something was wrong could not be fixed except by making the sun the center of the solar system. And so the new arrangement of the solar system was Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn. Okay, so that was the new arrangement of the solar system, and the moon still went around the Earth. That was revolutionary, and it was eventually confirmed by Galileo through the telescope, and eventually the new planets were discovered: Uranus, Neptune, and then, here goes, I'm going to step in it, but Pluto was discovered and considered a planet until 2006. Some of us still hold that Pluto was really still a planet, but that's officially it is not a planet at this point. But all of these bodies orbit the sun. Now, how could that be? It's counterintuitive. I mean, how does the Earth move, and then how do why don't we feel it? Okay, well, the answer eventually came through the discoveries of, in large part, of Sir Isaac Newton, who worked out what would later be understood to be the physics that would guide science really until Albert Einstein, where, although we still follow a lot of Newton's physics, it became more complicated than that. But the bottom line, at the end of the day, Newton discovered what's called gravitation. Gravitation is the tendency of clumps of matter or objects to attract one another. So the Earth holds us down, if you want to call it down, through gravitation. Now, there is no down in the universe. There's no such thing as down or up. The reason we perceive down or up is because down would be our being pulled by gravity towards the center of the Earth. Okay. Just speaking very simplistically, we'll say gravity pulls us toward the center of the Earth. As we move along, it might get more complicated than that. Now, we affect the Earth too. The Earth is pulled towards us also, but which is more massive? The Earth, right? So the Earth, the gravitation, that our body's gravitation affects the Earth very weakly, whereas the Earth affects us very strongly. So we are pulled down towards the center of the Earth. If we were on some other planet, we would be pulled down towards its center. So if we think about, here's Earth, my fist, and here's some other planet here, my fist, and I'm standing here on Earth. But if I were standing on some other object, I could be facing Earth, but see Earth as being up. So really, the universe is relative in that sense. It happens to be that the sun is not only the most massive object in the solar system. I'm going to have to go to part 2 here, so hang tight on this. Not only is the sun the most massive object in the solar system, but it has 99.8% of the, let's see, let's check that figure again. Well, let's put it this way. It's 333,000 times as massive as Earth. And it is the majority of the mass of the solar system, so it has the strongest gravitation. And so there is now going to be a tendency of the planets to be pulled in towards the sun. That makes the sun, in effect, the center of the solar system by definition. I mean, the Earth is not going to attract the sun nearly as much as the sun is going to attract the Earth. If the Earth were the size of a penny, the sun would be 6.7 feet in diameter. Okay? And if you look at the volume of the sun, it would fit about over 1 million Earths into it. Okay? 333,000 times as massive as the Earth. And now, of course, it's very, very far away. And we're going to get into, it is very, very far away. But still, it is so massive that it will gravitationally attract the Earth. Now, I'm going to continue with the solar system in the next video series, and we're going to discuss why the Earth doesn't fall into the sun, why it stays in orbit. We're also going to discuss, again, if the Earth moves, why don't we feel it? Hang tight.